Okay, so we are now here in the database section. Sorry for a second. So here in the database section, we are going to cover some of the database related AWS services. Those would include DynamoDB, Amazon OpenSearch, RDS, and Aurora. Okay, so we'll be starting here today with in this lecture with DynamoDB. So, okay, so let's get into the DynamoDB. So, DynamoDB is going to be a NoSQL database, fully managed, serverless, and can provide massive scale. It can go up to 1 million requests per second. It's going to have similar architecture to Apache Cassandra, and users of Cassandra can migrate to DynamoDB. For example, like there's no disk space to provision, and the max object size is going to be around 400 kilobytes. And the way to store bigger objects into DynamoDB is to actually store the objects into Amazon S3 and store a reference to that object in DynamoDB. So in terms of capacity, you have two modes. You have provision capacity. We specify how many write capacity units and read capacity units you want, and auto scaling on. Like you can use on demand, where you are going to have to pay for every single write and read, and this is better when you are going to have a more unexpected, unpredictable type of workload. So provision is going to give you almost the smoothest type of the scaling and a better cost, whereas on demand is going to give you going to be very helpful if you don't know the patterns in advance, the rise and drops of the traffic, your patterns in advance. So you are doing some development, etc, etc. So it supports it supports CRUD, create, read, update, delete, and the read can eventually or strongly consistent, and it supports transaction across multiple tables. So it's possible to get ACID support. With DynamoDB, you get backups available and point-in-time recovery, and finally you have two table classes, a standard for frequently assisted data and infrequently accessed for infrequently accessed data. So everything I said you should already know, but let's go back over the basics real quick. DynamoDB is made of tables, and each table has primary keys and must be created at decided at creation time. Those primary keys. Each table can have an infinite number of items, which are called rows, and each item will have attributes. So they are like columns that can be added over time, and it can be null event. As I said, an item can be bigger than like the 400 kilobytes. And in terms of data type supported, you have a scalar, a string, number, binary, boolean, null. You get document types such as list, map, and you get set types such as string sets, number sets, and binary sets. So these are the basics of the DynamoDB. Okay, now the primary keys. Primary key is important. So option one, you get just a partition key. It's called the hash, and in this case, the partition key must be unique for each item. The whole idea behind the primary key is the uniqueness, and so the partition key must be diverse enough so that the data is going to be distributed. For example, if you have a users table and user underscore ID is going to be a great partition key, so we'll have the partition key. Okay, and then we'll have a bunch of attributes such as first name, age, and this give us the kind of the users like these. Okay, so for John, there will be user underscore ID, and for Catty another user underscore ID, and so this user underscore ID is great, and we only have one. It's unique, so it's a great choice for a partition key. The other option is to use a So other option is to use a partition key that's going to be a primary keys. Okay, that's going to be composite, and so it's called a partition key plus a sort key. In which case here, what must be unique in the combination of the two? So the partition key itself can be repeated as long as the sort key associated with it is going to be different every time. So that the data is going to be grouped logically on the tables by partition key, and it's also common to see the sort key being called a range key. For example, if you have users in games table, and user underscore ID would be great for partition key, and the game underscore ID would be great for the sort key. So it's possible that a user has multiple games, but each game underscore ID and user underscore ID combination is going to be unique, and hence it's a great choice. Another good choice for short key usually is a timestamp. So you are trying to describe something that happens over time for a specific user underscore ID and so on. So you will choose user underscore ID for partition key, and you will choose a timestamp column for the short key. So here's the example for the user underscore ID and the game underscore ID. We have the partition key and the sort key that together as a composite key. They are unique, and the result can be some of the attributes. So again, here's an example have been given for this user underscore ID 12 1 2 1 2 1 2 a BR or something 45. Okay, then there's two games. Okay, then there's two games that have been played. One has won and one was lost. Okay, game underscore ID 1 2 3 4, game underscore 3 4 5 6, and one was 1 2 3 4 was won, and 3 4 5 6 went lost. So we can see the combination of the user underscore ID and game underscore ID in this case is unique, and we can do the partitioning on the user underscore ID. Now hopefully all of this is not surely the new to you anymore. Not even with you are coming from the associate certification, it's not new to you. Then we have indexes. Object is made of a primary key, a sort key that is optional, and some attributes, and so we can define some indexes on top of it. So the first one is the LSI, local secondary index. In this case, you need to make sure the primary key is kept, and you will just select an alternative sort key, and this LSI or local secondary index must be defined at the table creation time. It cannot be defined afterwards. Okay, the other index you have in case you want to change your primary key, then it's called a GSI, global secondary index. In this case, you can change the primary key, and you can also optionally have a sort key, and it can be defined after the table is created. So the idea in DynamoDB is that you can only query by primary key plus sort key on the main table and the indexes. So it's not like RDS where you can query any single column and any single rows. In DynamoDB, you need to think about what your queries are going to be, okay, and create the right indexes for these queries for it to work. So this is a major difference between the traditional RDBMS such as RDB Relational Database Management System such as RDS, and a NoSQL database such as DynamoDB. In our case, in DynamoDB, if you want to query something, you need to make sure an index has been created for it in advance. Okay, now DynamoDB is a point of the focus on the developer exam. DynamoDB is certainly the point of focus, a little less on the solution Architect Pro. So you don't need to know all the details, but remember between the LSI and the GSI, remember that you need an index if you want to query a specific attribute in DynamoDB. Okay, so some important features of DynamoDB. Number one is TTL, which is to make a row expire after a specific amount of time. We have DynamoDB streams where we want to react to changes to DynamoDB tables in real time. So this is a very common architecture, and this stream can be read by Lambda very commonly, or EC2. You get 24 hours retention of data in that stream. So here's a very common architecture, like you have create, read, update, and delete are done to a table, and anything that modifies that table, so create, update, and delete, will put into a DynamoDB stream, and that stream can be read by Lambda actually, and then that stream can be read by a Lambda, and then from Lambda you can, for example, put the data into Amazon ES Elasticsearch, Amazon ES Elasticsearch, or Kinesis if you wanted to have some downstream, maybe Kinesis Analytics application on top of it. So this is a very, very common solution architecture. We also have global tables where it shows basically a table that is going to be replicated across all your regions, and this is active type of replication. So you can have many regions, and for this you need to enable DynamoDB streams first, and it's very useful if you want to know if you want to have low latencies across access to data into different regions, or you want to create a disaster recovery as a strategy that's going to have a very, very low RTO. So here's an example. Here's the example. We have two tables. One is in the US East 1 and the other one is in the API Southeast 2. Maybe you're able to see that now. And whatever we do to the table on US East 1 is going to be replicated on the table on the API Southeast 2. And similarly, whatever we do in the API Southeast 2 is going to be replicated back into US East 1 table. So, okay, now you can use Kinesis data streams for DynamoDB streams. How does that work? So, well, we know that the DynamoDB streams will capture item level changes, but we now actually send the changes directly into a desired Kinesis data stream. Why would we do that? So, well, we only have 24 hours of data retention in DynamoDB streams, but with Kinesis data streams, we can get longer data retention period up to like even the 365 days. So also we could use the Kinesis related tool suites to analyze the data. So how does that work? So DynamoDB tables will push item level changes in Kinesis data streams, and then we can use, for example, Kinesis Firehose to read this data. Then we have and store it into the usual places. So Amazon S3, Redshift, or OpenSearch, or you could use Kinesis Data Analytics to analyze this data in real time and do some real-time computations such as some filtering, aggregation, transformation, and send that later on to the Kinesis data stream, Kinesis data firehose, or even the Lambda functions. So now let's get into the some solution architecture. So we know that Amazon S3 is not a great way to search for the objects because it doesn't have any indexing capabilities. And so what we want to do is to store some metadata information into DynamoDB. So the way it works is that we will do writes to an Amazon S3 buckets to add objects or update objects, and we'll have a Lambda function being triggered by the S3 events. This Lambda function is going to take the metadata of the objects we are trying to insert into Amazon S3 and insert this into the DynamoDB table. And the cool thing about it is that now we can create an API to search for the object metadata by creating the right indexes, the LSI and the GSI. So some things we can do thanks to this architecture, and is now we can say, okay, give me all the objects by date in Amazon S3, or give me the total amount of storage used by certain customer, or give me all the objects that have certain attributes. So by having these objects into S3 only, we could never answer this kind of queries, okay? And utilizing the DynamoDB, by having it in DynamoDB table, it comes be quite trivial, okay? So finally, let's talk about the caching in DynamoDB table. So DAX, DynamoDB Accelerator, you may be knowing this thing previously, and it is a seamless cache for DynamoDB. You don't need to rewrite your application, and all the writes will go through the DAX to DynamoDB. What this gives you is a microsecond latency, single-digit microsecond latency for cached reads and queries, which is very handy. It solves the hotkey problem. So if there is a DynamoDB, a specific row that is being read too many times, because it is very popular, then you are gonna get a threatening issue in the DynamoDB. In which case, like creating a DAX cluster in front of DynamoDB is going to solve that problem for you by caching that row and making sure it doesn't even reach DynamoDB. By default, your data is going to be cached for 5 minutes in your DAX, and there will be the TTL. Then the data will have to be refreshed from the DynamoDB. You can get up to 10 nodes in the cluster, and it can be multi-AZ, in which case AWS recommends you 3 nodes minimum for production. It's also secure you to get encryption at rest with the KMS and VPC integration, IAM, CloudTrail, and so on. And this is a default choice for a cache in DynamoDB. But we'll have a bit of a discussion into the write strategy right after. So the idea is your application wants to write to DynamoDB tables and read from them, and in the middle is going to be the DAX, and it's going to be the seamless for us, and it's going to cache the right rows and make sure we get the right performance where we need it. So So the question is from an architectural point of view, should you use DAX or Elastic Cache for DynamoDB? So as a very simple problem, when you have your clients who wants to directly access DynamoDB, then the right answer is to use the DAX, because you will scan, you will have the individual objects being cached, indexed, DAXed directly, and even results of your query and your scan will be indexed. But let's assume that your clients, after retrieving a lot of data, perform some heavy computation, and this computation can take, I don't know, like 10 seconds, 30 seconds. It can take that much long time. Then you will want to be able to cache the results of this computation somewhere, and that somewhere may be the Elastic Cache. So for example, Elastic Cache in this example could be a place where you want to store your aggregation results and make sure other clients can look into the Elastic Cache before getting the data from the DynamoDB to get the aggregation results. So it is one kind of architecture. You could also swap Elastic Cache for DynamoDB itself and have a table act as a case. It is possible, but I want to show you here the DAX and Elastic Cache can serve very different purposes. Okay, DAX is going to be for the individual object cache and for query and scan in like a scan cache is in the DynamoDB, where the Elastic Cache is for the whatever you want to put in it. So it's very possible for you to perform some heavy computation and cache them centrally in Elastic Cache. So to avoid going back to DAX and then DynamoDB and do some expensive computation again. Okay, so that's into the DynamoDB. Remember, it's from the architectural point of view. And this is all you need to know for the exam, and I will see you in the next one.